Good morning, everyone. Welcome to our presentation, Learn Live on Azure Networking Fundamentals. Today, my name is Matthew Bratschun. I'll be presenting with Brendan Stephenson. We're both engineers on the FastTrack for Azure team, focused on infrastructure and networking. Brendan, why don't you go ahead and introduce yourself?
Sure. My name is Brandon Stephenson. I'm a senior customer engineer with the FastTrack for Azure team in America's infrastructure. Excited to be talking to everyone today.
Great. Thank you, Brendan. And we can go to the next slide. All right, today, while we're presenting, we have two moderators who are going to be monitoring chat and answering your questions. We have Alejandro Palacios and Hubert Kudabaya. Please ask questions. This is a live event. They're happy to answer any questions you have related to the content we're presenting today on networking. And if you have a good question, they may raise that to Brendan and I, and we can discuss it as a group. All right, and along with the content today that we'll be presenting, we put together a collection on the Microsoft Learn site. And this collection includes links to a number of Learn modules that you can use to reinforce and extend what you've been learning here today around Azure networking fundamentals. We also have a link in there to a GitHub repo that has a lot of the content that we're presenting here today. And in there are a number of other links and resources that may be helpful to you. All right, I'm going to hand over to Brandon, who's going to go through what we're going to talk about today and get us kicked off here.
Sure thing. So Azure networking is a pretty broad topic. There are fundamentals, there are advanced concepts. Each resource can have its own networking patterns to follow, and different types of workloads can have different considerations. Our goal today is to not try and get our arms around all of those topics, but instead to cover what we think is a great foundational Azure networking set of information. We want to talk about some concepts and gotchas, some things that are different about networking in Azure versus networking in a data center. We want to go over some virtual networking basics to show you some of the fundamentals about how to build a virtual network and what different parts do. We'll also want to talk about DNS, the domain name service to resolve names in Azure. There's different options for that we'll talk about and explore. We want to talk about troubleshooting and other items with Network Watcher. And then we're going to get into some larger management concerns around the hub and spoke topology, a way to plan your IP address management for your Azure networking, and how it occurs in the virtual network. Now, all of these are topics that we're going to be digging into, but there are topics even beyond this that we aren't going to cover. So we're going to try and have a pretty narrow scope to help everyone be focused on the things that we think are important to have before you move on to more of those advanced topics. And I think the place to start with that is with the high level, what is different? Why talk about Azure networking as its own thing? Why, what are the things that we need to be aware of as you move your platforms into Azure? And so, Matthew, do you kind of start around what are some of the things that you think are important to talk about with regards to how networking in Azure is different from networking in a traditional data center?
That's right, Brandon. Yeah, there's a lot to think about in terms of what's going to be different from what you've been managing maybe on-prem to what you'll do in Azure. And a lot of that comes from the fact that Azure is now managing a lot of your network infrastructure for you. When you're working on networking in Azure, you're only going to be working at layer 3 and above. So anything you were doing on-prem that was kind of lower level, layer 2, layer 1, such as VLANs and that sort of thing, you're just not going to need to worry about in Azure, or not going to be able to worry about because the platform is going to do it for you. Along those lines, maybe on-prem, for example, you'd run a DHCP server to issue IP addresses to your devices as they connect to your network. In Azure, that's something that's going to be managed for you by the platform. So we'll talk about how you create a VNet and subnets later on, and how those addresses get assigned to devices as they connect. But you're not going to be needing to run a DHCP server anymore. Um, Similarly, thinking about like how you no longer have physical infrastructure, maybe on-prem, if you had a system that you were looking to increase the bandwidth on, perhaps you would add another network interface to that system and team the NICs or something to get a higher aggregate bandwidth. That's something that you're not going to be able to do in Azure because the amount of bandwidth available to a virtual machine that you're running in Azure is actually determined by the SKU or size of the VM. So if you do end up needing to get more bandwidth to a virtual machine that you have in Azure, you're going to need to change the size of that VM maybe to a larger size in the same family, or to even another family that would give you more options for networking. So those are kind of some of the fundamentals. Brandon, what are some of the design mistakes that you see customers make as they start implementing their network infrastructure in Azure?
Yeah, there's a lot of things that I think organizations try to do to leverage practices that they already have that just don't translate well into an Azure network. One of the big ones is force tunneling. Organizations will set it up so that all of their traffic in the Azure network needs to travel back to the data center in order to be processed, be inspected, and then go to the internet or go to its other destination. And that's something that isn't really recommended. It was maybe a pattern before, but it hasn't really panned out that well as being a good architecture pattern to follow nowadays.
Sure. And what are some of the problems that customers would run into with that?
Yeah, so I think the number one thing is you're building in some fragility into the system. If you do that, if you lose your data center, your Azure resources are lacking kind of key hops in their network flow. Building out your Azure network to be resilient and able to be operable on its own is, I think, way better in terms of having good uptime as well as having good performance. Performance is another one where you're now injecting a connection between. While VPNs and express routes are fast, it's not going to be as fast as using kind of the resources that are there. And Azure Region is able to send outbound traffic to the internet, and you can deploy things in Azure, like we'll talk about in a little bit, to inspect traffic and give you a security perimeter to your Azure network. So sending it on-prem just kind of adds additional delays, additional latency, and can make it harder to troubleshoot when something is going on because you've got to troubleshoot all the paths in Azure to all of your paths on-prem, and that I think creates things be getting really tangled up. And
Yeah, well, that makes sense.
yeah, and when you deploy those resources out, if you're hauling all of that internet traffic back on-prem, uh, all of your Azure resources that you might deploy in a network, such as an application gateway, which is a network appliance that can be used for website load balancing and can be upgraded with a WAF. Those communicate with the internet for Azure management plane traffic. They use certificate based encryption to talk to the Azure management plane so that you can go into the portal and update rules and deploy them out. If you're sending all of your traffic back on prem, that's going to break that pattern. And so you're going to have to constantly be thinking about every resource you deploy. How are you solving for that force tunneling? Some other stuff that comes up as well, public access. So organizations don't really map out what they want their inbound and outbound access flows to be, and that's really important. If you don't look at it, you might assume that if I have a virtual machine, like we'll be looking at later, that I'm not giving a public IP to, you might think that it has no outbound internet access, but that's not true. You'll have to use network security groups and other items to control that outbound access. And so not thinking about that can be a big challenge. Or just giving everything a public IP when it doesn't need it and giving the potential for inbound access. Again, you can use other items to control it, but thinking through, does it really need ingress onto a public IP is something that every customer needs to be doing. Um, there's also looking at that same thing not on virtual machines, but on platform as a service options like websites and SQL databases. Really thinking about that inbound and outbound and being thoughtful about what you put inside of a virtual network versus what you use kind of the platform native networking to do. There's lots of good things that you can do in that space, but they all start with looking at what you're doing and really getting an understanding for how does it work and what can you do to harden it correctly. And that hardening is a huge thing. A lot of organizations in their on-prem networks don't have a high degree of segmentation, and lots of little micro enclaves. And it's really ideal when you're migrating things into Azure to use network security groups, use good segmentation with your subnets, like we'll talk about in a little bit, to set up small security scopes and controlling access so that you can better control what can and can't talk to each other. The last big thing I'll say is not having kind of an Azure centric plan. I've seen some organizations take their kind of existing network footprint and say, I'm going to make every virtual LAN a VNet in translation. And those two things aren't really analogous. And so that's created routing issues, IP spoilage issues, security issues that come from that. So rather than taking what you have today and just moving it over, it makes a lot more sense to take the time to do some Azure network planning, take advantage of what's there, and use the tools kind of in the way that they should be used.
Yeah, those are great points, Brandon. Yeah, talking about not going into enough planning, it's all too common to see customers really focus on how they're going to deploy their network infrastructure, maybe get all the pieces put together, but forget to think about some other fundamental concepts like enabling logging in their network. If there's no log of the traffic flowing through your network and you have a security incident, you're kind of up a creek in terms of understanding how that moved throughout your network and what systems you have might be potentially infected. Another area that we see customers new to Azure kind of run into trouble is just understanding how to troubleshoot their network in Azure. And usually their first instinct is to go to tools that they've used on-prem. And the reality is that in Azure, those tools may not work the same or may not really be effective troubleshooting tools like they were on-prem.
Like,
A good example, or go ahead.
I was going to say, like ICMP, the pinging VMs is kind of a error-prone process in Azure if you're not set up correctly.
Mm-hmm. Yeah, that's a great point. So it's common for customers to want to use a utility like Ping. Maybe they use that on-prem, and they would like ping their default network gateway to understand a system's network connectivity, situation. But once you get to Azure, there is going to be no network gateway that's going to respond to pings for you. So the way you've used that tool in the past just doesn't work the same in Azure. Some other concepts to think about is in Azure, the platform is managing routing for you. So whereas in an on-prem environment, you may have used utilities like Route to set up routes locally on your systems for manual routing scenarios. In Azure, you're actually going to set that up at the platform level, not within the virtual machine. And we'll be talking more about that later on here. And then lastly, in terms of troubleshooting, a common gotcha that we see, too many customers run into is just misconfiguration around DNS. We'll talk about some of the places that you can configure the DNS services that are going to be used by your devices in Azure. But it's common to see scenarios like customers having a mix and match of maybe using Azure provided DNS and sometimes using their own DNS services, and then running into issues as name resolution is different between those two options. So those are some of the gotchas that we see and just items that we like to call out for customers new to Azure networking. Next, we're going to step into just some of the basics around VNets or virtual networks in Azure. Lauren, if you want to share my screen here. All right. So what we're looking at here is the overview page of a virtual network that I have deployed in Azure. And so there's going to be a lot of information on the screen, and I'm just going to focus on a few fundamental areas to call attention to them. First, I can see that each VNet that I deploy has an address space. So a VNet is essentially it's an isolated network that you deploy in Azure, that allows multiple devices or resources that you have in Azure to communicate with each other using private IP addresses. And by default, nothing's going to be able to get into the VNet that you deploy. And we'll talk about outbound connectivity, but pretty much a VNet is an isolated resource, just allowing your resources or virtual machines, for example, to talk to each other. So on the fundamentals of a VNet, we've got an address space. A VNet can have one or more address spaces assigned to it. So when a device connects to your VNet, it's going to get an address from the address ranges that you've assigned here. What you can do with this address space is also break it out into subnets. We switch over to a subnets view here. So the idea with subnetting a VNet is you're not going to want necessarily, or you're likely not going to want everything that you have connected in a VNet necessarily to talk to the other resources in the VNet, or maybe you're not going to want to treat all traffic within that VNet the same way. So when you divide out your VNet into subnets, so smaller sets of IP addresses, then you can use those subnet address ranges for specific resource types in your VNet. So for example, you could have a subnet in your VNet for your data tier of your applications. And then what you could do is use that address range that you've assigned to your subnet in firewall rules or in custom routes throughout your network. And you can treat that subnet and that traffic a little bit differently. But you don't need to go and specify individual IP addresses, say, for each of your database virtual machines. So that would be a reason to create subnets. In just a couple notes on subnets, so you can create your own name for subnets, but there are other subnet types that are going to require specific names depending on the associated resources. So just looking at this VNet that I have one custom subnet that I created, and then I have a gateway subnet, which is used for my virtual network gateway, which we'll talk about in a bit. And I have another subnet for my Azure firewall that's dedicated for that traffic. So looking at some other important items on this virtual network overview page, if I click on connected devices, I can see the IP addresses that are allocated to the devices connected to my VNet. This VNet does not have a lot going on. Basically, I have 4 devices connected to it. I have one virtual machine. I have the Azure firewall, and I have a virtual network gateway. But this is a good place to see the IP addresses that are being allocated to the systems that you have in your VNet. And then you can click through to those devices if you need to look into more details. Some other areas that you might look into on your VNet configuration page is the DNS servers configuration. We'll talk about this a little bit more in a DNS section of this presentation. But just note here that at the VNet level, you can specify the DNS servers that are going to be used for all the devices that are connected to your VNet. So you have, Brendan will go into details on what these options are, but just calling out, it's also possible to specify the DNS servers at the NIC level, so for, say, a single virtual machine. In general, it makes the most sense, we think, to specify it at the VNet level, again, so you're having a consistent name resolution experience throughout your environment. All right. So when we're thinking about VNets, there's a few connectivity scenarios that we kind of talk about. There's connectivity within a VNet, connectivity to a VNet from an external network, connectivity from a VNet out to the internet. And each of those scenarios has some different considerations. By default, within a VNet, everything that you deploy or that you connect to the VNet, even if they're in different subnets, are going to be able to talk to each other. And if you don't want to allow everything in a VNet to talk to the other resources in the VNet, you have a couple options, but primarily you're going to look at network security groups, which we'll talk about a little bit more here in a minute. When you're talking about connecting from a VNet to the internet, there's a default option built in, which is maybe different from some of the other clouds out there. When you deploy a virtual machine and connect it to a VNet, by default, that virtual machine is going to be able to connect to the internet through that default outbound access. And what that means is that when the virtual machine goes to connect to an internet IP address, that machine will be allocated a dynamic Azure Data Center IP address for that connection. So the traffic will go through and the system will be able to communicate with that network, that internet connected device. But on the other end, the source address for your Azure virtual machine is going to change because that's a dynamically allocated address. And you're going to have a couple options for that outbound connectivity that could give you a more consistent experience. One would be assigning a public IP address to your virtual machine's network interface. And when you do that, all outbound connectivity through that network interface is going to use that NIC's public IP address. So that's one option. Another option for outbound connectivity is to put the virtual machine behind a load balancer that has a public IP address front end. And then lastly, and the option we recommend for environments that are production or maybe scaling larger than just a really basic environment would be using NAT gateway, which allows you to specify a range of IP addresses that those systems will use for outbound connectivity. So that's kind of your outbound option. For inbound, we talked about virtual networks being isolated by default. And in order to get into a virtual network, you need to have a public interface associated with the resource that's connected to your virtual network. So what this means for virtual machines is associating a public IP address with that network interface. And that will allow you to use that public IP address to direct traffic from the internet to that virtual machine. And so that's one option for inbound connectivity to your VNet, but that's usually not what we recommend. Usually we recommend limiting the number of virtual machines in your environment that have public IP addresses, because doing so significantly reduces your security surface area. There's no way to the virtual machine except maybe through a firewall that you have deployed that does have a public IP address. So that would usually be a better approach. Or if you're only using a public IP address to manage your virtual machine, like through RDP or SSH, the Azure Bastion service offers you a way to connect to those virtual machines without needing that public interface. So next, kind of in our connectivity scenarios, we have hub VNet, or our connectivity between VNets. So with VNets, you're isolated by default, but it is possible to connect VNets together. When you have a hub and spoke model, for example, you can create what's called a VNet peering that connects one of your virtual networks to another virtual network. And when you create that peering, the platform goes and adds the routing that you need for your devices to connect between those virtual networks. And Brandon's going to be talking more about topologies where you'd be using VNet peering later on. But peering, you have a couple options for peering to think about. There's regular peering, which is what we're looking at here, and you can also do global VNet peering. So by default, a virtual network only exists within a single subscription and within a single region. So if your Azure infrastructure is going to span multiple regions or multiple subscriptions, that means you'll have to create multiple VNets in your environment. And chances are you're going to need the resources in those different VNets to talk to each other. And if the VNets are in the same region but different subscriptions, you could use VNet peering to connect them. Or if they're in multiple regions, you can use what's called global peering to enable connectivity between those VNets. All right, and then our last scenario is connectivity from external networks. So this would refer to networks that you own that are external to Azure generally. So this could be your on-prem network. You could have a setup in, say, another cloud provider that you need to access your systems in Azure using its private IP address, addressing. So you have a couple options for this connectivity from external networks or hybrid connectivity in Azure, and primarily that looks like either a site-to-site VPN connection or an ExpressRoute option. And we're not going to go, we don't have time today to go into a lot of details on VPN and ExpressRoute, but we're hoping to do another session at the beginning of next year where we'll go into depth on those. But what I'm looking at here is a virtual network gateway that I have connected to my hub VNet that we were looking at earlier. And what this does is enable me to create VPN connections from an external network to this virtual network gateway and allow me to access the systems that I have deployed within that VNet. So that's the virtual network gateway. All right, and then let's see, lastly, so we talked about connectivity within a virtual network being free-flowing by default. So between subnets, traffic is allowed. So one of the ways that you can restrict that traffic, and probably the way that we recommend, at least as your starting place, is to use what we call a network security group or an NSG. So an NSG is a basic firewall, with limited functionality, but you can define security rules in it that allow or deny traffic based on source and destination ports and protocols. And so you define that NSG and put security rules in it. And then you can associate that NSG with either a subnet or a network interface that you have in your VNet. And that will allow you to both limit, so you can either allow or deny inbound or outbound traffic to and from the internet, or within the VNet or between your peer VNets. You can create rules that will limit that traffic to meet your requirements. So what I'm looking at here is a network security group. And I'm just going to real quick look at the rules that exist in this NSG. So these rules that start with 65,000 are what's called the default rules in the NSG. So when you create a new network security group, those rules are going to exist by default. And just looking at these real quick, this first rule is allowing any traffic within the virtual network to source or destination of the virtual network. So you're still allowing all traffic within the VNet. If you want to limit it, you would have to add a custom rule with a higher priority. We're also allowing all load balancer traffic. So this will make sure that if you have a load balancer in front of virtual machines that you've deployed, that both those health checks and that traffic to those backend virtual machines is allowed from the Azure load balancer. And then lastly, we have a rule that if the traffic doesn't match either of these other two defaults, then go ahead and deny it. So this means that when you've created an NSG, you're by default denying traffic from the internet. So then you have to go and allow traffic if you want traffic to come to your virtual machines. And of course, your virtual machine also would need to have a public IP address or one of the other options to enable public traffic to the virtual machine that we talked about. So I have a couple rules added here that in this case are allowing management traffic on non-standard ports just to the virtual machines within this subnet. So some questions we see customers ask around NSGs are, should I be using an NSG on every, on all of my virtual network infrastructure? If I already have like an Azure firewall or other central firewall appliance deployed, do I need to be using NSGs? And the answer to that is that we do recommend that you do deploy NSGs so you have a defense in depth strategy there. And NSGs also enable you to configure that logging that we talked about earlier through NSG flow logs, which we'll go into a little more in our management section here in a minute. All right, let's see. I'm going to hand off to Brandon here, who's going to talk about some of the details of the DNS services that are available in Azure. So we talked about where you could configure it within VNets. Brandon will talk about what those services actually are and what your options are.
Yeah, so DNS is a really interesting thing. I tend to take when we're looking at workloads in Azure or workloads anywhere that DNS is guilty until proven innocent. It's one of the kind of most frequent areas for odd issues to occur. And there are some different things in Azure that make DNS really easy, but you also need to be aware of. And organizations that start building out Azure virtual networks but don't make a decision or think through the DNS ramifications can run into issues down the line. So, what I'd like to do now is talk a little bit about what is available, what is needed and essential, so that you've got context for looking at these and making some decisions for your organization about how you might be using this. So we have here a virtual network in the portal, and you can see that I've got an option here for DNS servers. I can set things to be default, Azure provided, and that's going to be using the Azure provided name resolution. That's going to let me resolve anything that's in the virtual network of the same VM. So it lets me use the Azure VM's resource name to do some domain resolution between items. That's nice and makes things work pretty well in small networks, but it isn't kind of the biggest platform overall. It's effective and it works, but a lot of organizations need to extend their existing enterprise DNS in. And so there's options to set up your own custom DNS servers by setting this to custom and then adding them in. Now, this one here, this 168 IP address is what's sometimes called the magic IP in Azure. This is the domain name resolver IP. And so what I have here is a setup of saying, hey, use my private DNS server, which could be a virtual machine that's set up as part of my Active Directory or other items. It could be Infoblocks or any other VM-based DNS resolver I want to bring over. But if that's not available, fall back on using the Azure default DNS to get some of the name resolution there. I can also set this not at the virtual network level, but also on the network interface as well. I can tell it the individual network interface to inherit the DNS from the virtual network or have something custom here. Now, a call out with these is that this sets it for the VM when you reboot. So if you're in the middle of troubleshooting this and you're wanting to make sure your DNS settings are propagated down, the virtual machine itself should be rebooted, powered off, powered on inside of the Azure portal in order to make sure it's getting the right inheritance here. In addition to just the Azure name resolution and bringing your own DNS servers, you also have the option to use private DNS zones and DNS zones in Azure. And these are, I think, a little bit confusing because their names are very similar, but they do very different things. Private DNS zones are zones that you can attach to a virtual network. And from that virtual network, it will be added to the list of names resolved by that virtual network's Azure provided name resolution. So I can attach this to a virtual network. I can fill this out with my DNS records. And then now my VMs in that virtual network are going to forward their requests to the Azure provided name resolution. It will have this zone, and I'll be able to get IPs back from that. This is really helpful for kind of fundamental resolution of things to other network spaces on-prem, or the resolution of things that are in virtual networks that have some obscurity to them. If I want to resolve a friendly name to a resource, I can do that through these without having to deploy additional servers. I can also enable auto registration. And what that means is that my as I add virtual machines to this virtual network, they're going to be added to the domain, the name zone that I have here. So if I add VM1 to the virtual network where my private zone.net is linked with auto registration, I'll see a record in here for VM1, VM2, VM3. And so that kind of works for a very lightweight way of resolving more complicated names to a zone, or to have friendly names for websites and things like that be resolvable inside of Azure. Private or public zones operate pretty differently. They have the option to still add record sets to them and have name zones on them, but instead of being tied to your virtual network, they're tied to where you actually own the domain itself. So you would use these name servers here with your registrar to handle DNS resolution, basically letting you control your DNS names from inside of the Azure portal by sending public requests to these name servers. And so if we're talking about building out your Azure virtual networking, the DNS zones don't really get used that often. They're really for the public resolution. If you want to take a name and have it resolved to a firewall or gateway or some other service, that's where this comes into play. Whereas the private zones will let you extend out the basic Azure provided name resolution with your own domains and custom configurations. You can also have what we kind of call a hybrid DNS option, where you have a custom DNS server, so imagine 2 domain controllers with the DNS role, with a conditional forwarder to that magic IP address that we talked about, the 168 IP address that front ends the Azure provided name resolution. In that case, the behavior that you will see is your private DNS servers, your domain controllers or info blocks, will try and resolve all the things that they have records for. If they don't have records for items that you've set up conditional forwarders to, they'll forward that to the Azure provided name resolution, which can then use its own resolution or any private DNS zones that you've put together to resolve those. And that's very important when we're working with platform as a service options that are using private endpoints. So that's a very kind of key part of that. And it also enables you to resolve the Azure DNS from on-prem by conditional forwarding things in a certain way. There are other options as well, such as having a private resolver to kind of replace that those custom DNS VMs for forwarding DNS queries from on-prem data center or branch offices into Azure to get to resolve against your Azure private zones. But that's a little bit out of scope here. What I think is important is to know that you need to have a DNS, and that you're probably, if you're in a VM migration scenario, you're going to be bringing your custom enterprise DNS solution with you, setting it as a custom DNS server in Azure, and having that operate through. You're not going to be using the Azure provided name resolution for your virtual machines if they're part of kind of a mixed hybrid environment. And so you'll really want to have a plan for adding DNS servers to Azure, having conditional forwarders if you need them, and setting your virtual networks to have your custom DNS servers be available.
So Brandon, would you say that customers, new customers to Azure, should plan on building their own custom DNS servers, or should they plan on starting out with Azure's either private DNS zones or built-in options?
So I think it depends on the workload. And let me give an example. If we're migrating virtual machines from your data center into Azure, and those are Windows Server machines that are already domain joined, then I think it makes sense to use an extension of your Active Directory DNS to use that. You already want to have your domain controllers, a copy or a node, a replication site of your domain controllers in Azure so that your virtual machines in Azure can be domain joined to them and operate. So you're bringing them over anyway, bring over your DNS as well. Don't try to re-architect your DNS if you are doing a migration of existing domain joined items. But maybe you're doing something that's a little bit more of a proof of concept, or maybe you're doing something as using virtual machines. You're using a Kubernetes instance, or you're consuming some kind of service that isn't going to be domain joined, or you are using some other mechanism with new VMs for the authentication area. Instead of using Active Directory for group policies and authentication, you're using Azure AD join and Azure guest policies to set the state of those VMs. If you're doing that and you kind of decoupled from Active Directory, then you should probably look at using a private DNS zone attached to the virtual networks with that auto registration, and then maybe private resolver to be able to resolve from on-prem and vice versa. But it really depends on the workload. As just like a really rough shorthand, migrations, probably bring your own. New workload that isn't AD joined, probably try and use the native as much as you can, unless there's some business reason around it, like you have automation for your info blocks and you want to continue to leverage to use that information or that automation.
That makes sense.
Yeah, it's not like a one size fits all, but it is, there's some t-shirt sizing with that. One thing I'd also say, just to that point of deciding which of these DNS services to use, um, the public DNS zones are really helpful for workloads in Azure where you're wanting to give custom domains to application services later on. Managing them from here is a lot easier. So if you're deploying out a new workload for a new DNS zone name, really look at using the DNS zones to reduce the different systems you have to manage in. It doesn't help you with kind of the private DNS story, but it's really helpful to be able to push settings to it from something in order to be able to register to an app service or to a front door instance and all of those other services that care about DNS to confirm that you own the domain before they let you start using it. So that's the kind of DNS scenario in a nutshell. But of course, DNS is not the only thing that's going to break for you. So there are other things that are going to make sense to investigate. So Matthew, do you want to talk maybe about where we go to investigate VM to VM connectivity issues?
Sure, Brendan. Yeah, if we can share my screen. So we talked earlier about some of the differences in tooling that you may have in Azure versus what you used on-prem for troubleshooting networking. And in Azure, there's kind of one primary suite of tools that is a great thing to keep in mind as you're troubleshooting your networking in Azure. And these all roll up under the product called NetworkWatcher. And actually, if I go to the overview page for NetworkWatcher here, I can see a bunch of NetworkWatcher resources exist, one for every region. So you don't need to actually deploy NetworkWatcher resources. It's done automatically by the platform. But you will see, once you create a VNet in Azure, you will see a NetworkWatcher resource group get created and a NetworkWatcher resource in there. And that NetworkWatcher resource just enables the diagnostic tools that we're going to be talking about here. So just starting with some of the monitoring that you can do with NetworkWatcher, there are a few different monitoring options listed here. The Connection Monitor Classic and Network Performance Monitor are kind of the two legacy options that are being phased out. And everything's moving towards these connection monitors. And what connection monitors allow you to do is install an agent on a virtual machine that you have in Azure or even on-prem, and configure monitoring of a specified network test. And that can be basic, just as a port alive, or it can be more complex, like a HTTP request, and maybe looking for a specific status code in that response. So network monitors are a great tool to monitor the ongoing health of your Azure network environment. So if I expand what I've got deployed here, I'm just going to click through to one of these, and kind of show what the sort of information that you can get from Network Monitor. Give it a second to load here. But this is a great tool to see, like, over time, what's the status of my Azure network. In this example, I have a monitor on an on-prem device and one in Azure. So by setting up connection monitor between those devices, I'm able to see my round-trip latency over my hybrid connection to Azure. In this case, it's a site-to-site VPN. And this would be a great place to look, say, if it seemed like things were slowing down in the middle of the day as everybody got busy at work. You might notice that you have latency, you have spikes throughout the day where latency increases when everybody's busy, and that may be a good clue that perhaps you need to increase your number of VPN connections, increase your gateway skew, or consider moving to an express route connection, which might have more bandwidth than what you're getting with VPN today. You can also monitor, connections failed, or connection checks failed. So in the scenario between an on-prem and Azure environment, this would be a good tool to see, monitor from your VPN device on-prem. Say you have one that seems to be restarting in the middle of the night or something. You might see those checks failed happening consistently and be able to investigate that in more detail. So I'm going to go back to the main connection or network watcher page and go through a couple more tools that you're going to find here. So when we're thinking about troubleshooting networking in Azure, or probably even on-prem, a big area of concern is, can the traffic get to its destination, or is it being blocked by a firewall along the way? So in Azure, we talked about using NSGs as those basic firewall rules, and a way to troubleshoot your NSGs that you have deployed, or see if a specific rule is blocking or allowing traffic, would be to use these NSG diagnostic and effective security rule tools under Network Watcher to see how those rules that you've created roll up. So for example, a scenario that might be difficult to troubleshoot is you have an NSG that's associated with a virtual machine's network interface, but you have another NSG associated with the subnet, and maybe you have Azure Virtual Network Manager admin rules applied above that. And this effective security rules could show you a roll-up of all those rules and see the sources where things are coming from. And NSG diagnostics would be another tool that would let you actually see whether traffic would be allowed or blocked based on the rules that you have defined and the traffic that you're trying to allow or block. So beyond firewalls, the next common area that we see networking troubleshooting, customers need to go into for network troubleshooting is routing. So even though I have my traffic allowed through all my firewalls, that's not going to matter if the traffic is not able to route from the source to the destination. And so the default routing in Azure will pretty much allow all your traffic flows that you'd expect. You usually don't need to touch it. starting out. But we'll go into this more later, but once you start adding like hybrid connectivity between Azure and on-prem, or adding network virtual appliances, you'll probably start then needing to add custom routes and route tables. So this tool in the next top allows you to see for this traffic, leaving the specified virtual machine and going to the specific destination, where is it going to route to next? So for example, if you want to make sure all your traffic flows through your Azure firewall, but this traffic doesn't, you're seeing traffic or you're not seeing traffic on the firewall that you expect, you could use this to help diagnose that issue for you. And then a couple other diagnostic tools that are available in Network Watcher. There's packet capture and VPN troubleshoot. And these are great ways to get more in-depth information when troubleshooting, just general network issues, or maybe application level network issues, or if you have a VPN connection that you're having trouble with maybe establishing the security associations, something like that. These two tools will give you that in-depth information. And packet capture can be a helpful tool, especially if you're looking to get a packet capture, but you're not able to access the virtual machine. Maybe you don't have permissions. You're specifically a network admin, but this packet capture could enable you to get the packet details that you need. Let's see, and then a couple other tools that are part of this Network Watcher view. So we talked about network security groups. Those have a feature called flow logs on them. And what you can do with flow logs is log all traffic that flows through an NSG. And that can be a great tool for security and for troubleshooting your network. So this page in Network Watcher gives you a place to create flow logs and also to browse the NSGs that you have out there. And then the last tool that's part of Network Watcher to call out is this traffic analytics. And this is basically a layer that goes on top of those NSG logs that enables the Azure Log Analytics service to perform analysis and storage of your NSG flow logs. And let me hop over to a view of that real quick. Sometimes takes a minute to load here. But traffic analytics, yeah, gives you an easy way to visualize your traffic, an easy way to query those NSG logs. And it'll show you like, on these dashboards, I can see if there's blocked or malicious traffic that's flowing through my NSGs where I have flow logs enabled. It'll also give you like topology information for your network environment in Azure, which can be a great way to see like a high level view of your network infrastructure. So a number of other views that are helpful to see. I don't have a lot of traffic going through here, so there's not a lot of data. But imagine you had a large, multi-VNet deployment with a lot of systems in it. This traffic analysis could be really helpful to get to the bottom of some of those details. All right, so
I was going to ask a question. So there's lots of tools here,
mm-hmm.
but kind of what's the order of using them? If I'm trying to troubleshoot an issue, where do I start? What are some of the places to go into, kind of the order that maybe some of these are used, or situations that call for one and not the other?
Yeah, so that's a great question. And actually kind of leads into where I'm going next, and I'll come back and talk about some of the Network Watcher tools. So beyond Network Watcher, there is also another suite of basically visualizations available in Azure for your network infrastructure. And let me get my subscription up here. So Azure Monitor has a feature called Insights. And Insights are basically dashboards, pre-created by Microsoft, showing you a high-level view of the resources that you have out there. And if we navigate to Azure Monitor and look at the Networks Insights pane, this is a great place for like high level troubleshooting. Like, you have several people reporting network issues all at once. And that probably points to some network infrastructure problem. So you can see here in this main view, I can see the status of some of my primary network resources, my virtual network gateways, my network virtual appliances, load balancers, etc. So if you have an issue that's like a big, seems to be impacting multiple people, I think that this network insights in Azure Monitor is a great place to start narrowing down the issue and dig into the health of your resources there.
So,
If
uh,
Go on.
so to the topic of the troubleshooting situation, start with the Azure Monitor network insights to kind of narrow down where it might be, then go into network watcher and start using specific tools to test kind of specific areas that network insights kind of told you to look at.
Yeah, exactly. And if you have an issue that seems to probably be scoped to a single virtual machine, then you're probably going to be instead of going straight to the Azure Monitor Network Insights, you might be more likely to be looking at these network diagnostic tools like NSG Diagnostics or Nextop Verify as you're trying to troubleshoot that networking issue. Let's see, I think that covers our main topics for Azure network monitoring. Brandon, so we've talked about a lot of the different pieces in Azure networking. And next, let's have you talk about just what we call our hub and spoke topology and how we kind of put all those pieces together.
Sure. So switching over to my screen, we've talked about a lot of all the fundamental building blocks in Azure Virtual Networking. Now let's talk about building out a kind of enterprise type of network here. So this is a reference image for our hub and spoke topology. This is one of our most common topologies. There are other topologies that are perfectly good, but I think what we found is that the pattern is that this topology makes it easier for customers to adopt, and so is a good kind of first thing to look at to say, if I'm shifting some resources into Azure and I want to set up a network that's going to scale really well, that I'm not going to have to redeploy later and I'm not going to run into some growth issues for quite a long time, this is a network topology to look at. In it, we have a hub network, which basically acts as a DMZ between all of these different spoke networks. That hub network has network appliances in it mostly, things like firewalls, VPN gateways, services that we'll talk about as well that are good for hybrid connectivity. And then any workload or set of services is deployed in their own spoke. We'll talk about what goes in a spoke and how to size those in a little bit. But the takeaway is that each spoke network is its own constrained security context, that to talk to another spoke, it needs to go through the hub and the security perimeter there. To talk to the internet, we would also want it to go through the hub and to the security there. And to go to the corporate environment, same thing. And so that kind of exchange means that I can scale out my network really easily by deploying out more spokes. I don't need to have one network that is very heavily integrated, and my routing becomes a little bit simpler. There are some other things as well. Cost is a major driver for this. If we look at a example hub, we have some resources that are a little bit expensive. The Bratschun service, which is something that can be used to allow for a secure MFA RDP into the VMs through a browser session or through a client backed by Azure AD. We have Azure Firewall, which is our firewall platform that can be used for TLS inspection, can be used to apply web category rules and to have your own access and deny controls in place. Our VPN gateway, but there may be other services as well that you would want to have in here, and you would want to have available to many different virtual networks without having to deploy another one. If we were to say have a security context for workload X and a security context for workload Y, and they both need their own firewalls, gateways, and bastions, that is something that can add up as we scale. And so by having one shared hub, we help consolidate some of those costs. We also help consolidate the management. We have a consistent routing, consistent connectivity flows, and it's easier for us to delegate permissions. In this context, if I give a virtual network to some workload team that's going to be deploying VMs, I can have some confidence when combined with things like Azure policies and some more advanced items, but I can have confidence that if it's associated correctly with the hub, my hub security perimeter is going to be applied there. And security is, one of the other big drivers behind this. It gives us a strong environment in each of these spoke networks that is hardened against every other spoke network. So I don't have to worry that much about network bleed. I don't have to worry that much about having resources in one area inadvertently have access because I've misconfigured an NSG. An NSG can be used to block traffic, but it's kind of nicer to not even have to worry about that and just denying it by default. And having different spokes with the hub in between them lets you do that. Now the general flow that we want to have is that the security perimeter is, or the security boundary is in that hub. And so we would have the services that are in each spoke flow to a firewall that would then source NAT and send things to the internet, or possibly send things to the corporate environment without natting the IP address. And that firewall acts as a both enabling of secure communication and a way to control the outbound IP addresses from the items. If you need to whitelist, or sorry, if you need to set it up so that you have specific public IPs associated with your firewall that a partner can trust for some type of communication, then you would have that that ability in that firewall. And same thing if you are needing to relay things into the corporate environment. It is, I think, really helpful to delegate all those security resources into one place and one location. Let's look at how this looks in the portal, because seeing is kind of believing here. So here I have a hub resource group where I have my virtual network and a variety of different resources here. Basically, the idea is that in this, it's one resource group with all the things for shared connectivity in one place for me to manage. I've got my ExpressRoute gateway, I have my VPN gateway, I have my firewall, and I have my virtual network. And so this virtual network is, like we looked at before, peered to some other networks. It's partitioned out to have the subnets for my resources, but it can be peered to my spoke networks. And these peers are set up to enable the virtual network gateway that's in my hub to be used by all of those locations. But there's some other things here that I think are relevant to call out. One is that the gateway is located here as well. And so if I need to set routing controls on it to inspect resources, I can do that by manipulating this network. And if I need to add and extend out other resources, I can do that as well. And so what I end up with is, if I look at my VMs, my VMs will be sending their traffic to the firewall for really any scenario that isn't inside of their virtual network. And so each of my virtual network spokes can communicate to each other constrained by network security groups. But for all the other items, I'm sending them over to my firewall for inspection and to follow the controls there. And so I can give a workload team the ability to have their resources talk to each other and encourage them to micro-segment out, but I'm able to set up a much more forceful control on the inside of the firewall itself. Now, we'll talk about how some of this routing works, but the main takeaway that we want to have from this is that anything that is talking to anything outside of its spoke, we want that to come in through the hub as a security boundary, as a way to reduce management by setting up a firewall rule that has the right controls and being able to use that consistently.
So Brandon, I could see customers saying that this looks like a lot to manage, multiple VNets. How would you respond to a customer who said, I just want to use a single VNet because it's easier?
Yeah, a single VNet is kind of an interesting situation. So if I have a single virtual network, and let me pull this back up for an example. If I have a single virtual network, I have to forcefully set my NSGs to micro-segment it out. So if I have one big virtual network and I have different security scopes, my NSGs are the only thing that's giving me security from there. I'm able to route by default. I'm able to do all these things by default. The NSG is the control. And if I want to say micro-segment them out to say, okay, well, I'm going to make a subnet for app X, a subnet for app Y, a subnet for app Z, and I'll NSG block them, that can work, but those NSGs now become very important. And you've got different NSGs to manage, or one large NSG, which is kind of like managing one firewall policy for the whole environment, which can get a little bit complicated. But it still has the ability to route on its own. And so if you misconfigure that, it can slip through. And inside of a virtual network, it can be a little bit more difficult for that. You also really ramp up the complexity of sending things to a firewall for inspection. We'll talk about this more in routing, but each of these spoke networks, any given virtual network can route to itself. And so if I have one large virtual network, if I want to have things route to the firewall instead, I have to set up specific routes. I can't just say deny or block all routes. I have to go in and say, if you're trying to talk to your subnet, go to the firewall, or this sub virtual network, go to the firewall. So
Yeah.
having it so that like things in a subnet can talk to each other without inspection, but things that are in a virtual but can't talk to other things in the virtual network becomes really hard with one virtual network. And it is uh, not a great experience to try and break it apart later. Um,
Yeah.
you you can't just move a virtual machine to a new virtual network in the same way that you can move it around to a different subnet. And so keeping it starting off with it there means that later on, if you need to break it out or you want to have more boundaries, you can do that. You can always let things talk to each other through peering, but you can't really break something apart without almost a redeployment or a disaster recovery like scenario. So while it may seem like too much to manage, it's actually not once you get into it, and it's going to save you a lot of headache later. I've had a lot of customers that have had to do this kind of migration, in place migration, and I it's not a great way to spend your day.
Yeah. So it sounds like either way, there's going to be a lot of complexity to manage. If you're trying to put everything into a single VNet, then you have a bunch of NSGs and routing complications. If you break it out, you're going to have multiple VNets to manage, but in the end, it'll be easier to do so consistently and at scale.
Yeah, and I would even say that if you take the time to like read this Architecture Center article that's in our collection for this, so if you go in and look at the articles that we've linked to for this session, this should be in there. It tends to actually not be as complex. I've had customers able to get up and running with this very quickly once they kind of take the time to understand these fundamentals
Mhm.
that we've been talking about here. Now, there's maybe some situations where hub and spoke isn't always a good fit. If you're setting up a workload that doesn't need a firewall and doesn't need to have connection back to on-prem, it can probably be in its own virtual network. But those scenarios, I think, are fewer and farther between.
Mhm.
Um, Well, let's talk then about the next layer of this, which is how do we plan our IP address management for all of this? So, what I want to talk about here are some examples and tips for planning your IP space assignment. Um, it isn't something you need to follow 100%. This isn't strong, this isn't prescribed guidance. This is just one model to look at to start thinking about how you want to size it up. What works right for your organization is going to be the best thing. But IP address spacing is something that's a little bit hard to change. It's gotten easier over time, but changing the subnet that something is in, if it's an appliance, can be difficult. So, like, you can't really move an Azure firewall to a new Azure firewall subnet with a different IP range without really redeploying the whole thing. So, to save your time, we want to talk about some guidance on that. And one aspect of this is two kind of big things to keep in mind. Don't fear over allocation, or rather, don't over fear over allocation. If you are already in an environment where you are running up against IP address exhaustion, then realistically, you do need to look at that. But most organizations, I think, are in a little bit of a better spot for that and don't need to worry about that. So if you're fine, don't make things more difficult for yourself just so you don't maybe run into it later. The other thing is, don't import your old IP space or your old IP space considerations. Like, don't just extend it out in the same way of like a virtual network as a VLAN or a subnet as a VLAN. That's going to not really line up really well. So step one is to define a supernet. And this is not a thing that exists in Azure. This is a kind of a thought experiment or a thing to have in mind as you are moving forward. Take a /16 and give one to a primary region where you're going to host all of your main workloads, and then another to a secondary region where you will host secondary workloads and use it for disaster recovery so that you can have your DR region set up. Even if you're not doing the DR just yet, go ahead and plan for that so that you have some consistency in your IP spacing. So 10.1.0.0/16 is my primary region. 10.2.0.0/16 becomes my secondary region. There's no Azure construct for this, so you'll want to record this in your IP address management system, which could be anything from a complicated tool like the Windows Server IP address management, or something relatively low tech like an Excel spreadsheet. But having it called out is going to make things a lot easier for you later. Afterwards, take the first /22 from those and assign those to your hub. Your hub can be some different sizes, but /22 is a good, generous allocation for those. Once you have those in place, you're able to start carving out spokes really well. And so you'll end up with something that looks a little bit like this. For the hub, we're going to be giving a /24 to a gateway, /26 to a /24 to the Azure firewall. You can see here in this diagram, it's got a firewall subnet and a firewall management subnet. That's a consideration for force tunneling. You also have a /27 for Bastion, and you can begin to deploy out other resources that you need for networking. If you have special networking security appliances that you want to use, they could fit into this structure as well. And so you're also going to have plenty of room for spare things to come across later. So /22 is a good, healthy, generous amount that will get you running and give you plenty of room to grow. You may have to change it later, but it's become a lot easier to add IP address space to an existing virtual network now. And then you're going to be giving resources to your spoke networks. And the spoke networks are a little bit more difficult to IP size because they're not at all one size fits all, because of the nature of each one being its own security context from a network side and security context from who is delegated to administer that network and deploy VMs to that network. There's a little bit of art to deciding how big you want to make them and where those come in. So to make that a little bit easier, you'll want to be thinking about the way that the resources in your virtual network are going to be micro-segmented. And what that means is giving resources their own subnets so that you can apply NSGs to them in a in a controlled way. And so you can associate the right amount of IPs to them. So rather than say we're going to give every workload a /24, look at it and say, well, what are the tiers? What do we have? How many? How much do we need to plan to scale this out? Are we going to do auto scaling? Because auto scaling resources, one of the big bottlenecks for that can be number of IPs in their subnet. One large subnet is able to host something that can auto scale up bigger than a small subnet can. And so think about the way that the workloads that you're talking about are constructed, how you can segment them into tiers or functions, what tiers and functions need to talk to each other, and how they're going to need to scale. And once you've done all of that, you could consider doing something with t-shirt sizes, where based off of the type of environment you are that you're moving, you assign a t-shirt size to give it a general size to start off with. Here we can talk about small, medium, large, and extra large. A small might be a /26 that gives you 64 IP addresses -4 per subnet. And that's ideal for a really small web app or something else that doesn't need a lot of IPs, is simple to manage, doesn't have many tiers, isn't going to auto scale a lot. Medium /25, 128 IPs -4 per subnet, because the first 4 in the subnet are going to be consumed by Azure's management plane. All of that stuff that Matthew was talking about that you're not going to be managing, that kind of eats up those first 4 IPs. So again, with this, maybe we're auto scaling more. Maybe we have a couple of tiers. When we get to large, a /24, 256 IPs -4 per subnet. Here we're talking about a big workload. Maybe it's got many tiers, or maybe we have a bunch of virtual machines that are all managed by the same team, and we want them to be in one network for security context, and they're going to microsegment out them for network for NSGs. Or maybe they're using some services that are IP address hungry. Attaching VNet integration to an app service can demand a certain number of IPs associated with it, and so we want to plan that accordingly. Extra large, 512 -4 per subnet. That's going to be for really large workloads, possibly for like a data center migration, where if we say, hey, our plan is we want to migrate a data center into one virtual network, we're going to subnet microsegment it there, but then we're going to begin to retire those infrastructure and deploy them out in small and medium virtual networks based off of their workload. Extra large might help you accomplish that. Or having a really monolithic application that's using a lot of different services, or is going to be wanting to scale up a whole lot, is another thing that can be good for. And so if you kind of set these up, look at the workload and what its IP address needs are going to be, you can size your spokes pretty well from the get-go. So we have, and so if we're thinking about what that looks like, then we'd have our hub with the /22, small, medium, and large spokes, and possibly have our identity services in their own spoke as well that would be on a smaller size, and give us a kind of clear mapping for how we're assigning IP address spaces and what's available for additional consumption later on. With all of that in line, I think it's probably time for us to talk about routing and how that's going to fit together. We'll keep that at kind of a high level, I think. But Matthew, do you want to take it from there?
Yep, yeah, if we can share my screen. So we talked about routing a bit and shown some of these tools for troubleshooting routing already. I'm just going to spend a few minutes digging into a little more detail in terms of the troubleshooting and understanding what routes are being applied to a virtual machine that you have deployed in Azure. There's a tool called Effective Routes, and you can find that by navigating to the virtual machine's network interface. And then if you scroll to the bottom and click Effective Routes, you can get a view of the routes that are currently being applied to the virtual machine. So the virtual machine actually does need to be on for this list to be generated. But you can see that I've got a few different routes that are deployed here. And the routes that you'll probably be using in Azure probably serve a couple purposes that we've talked about a little bit. But you might be trying to route traffic through a network virtual appliance, such as an Azure firewall or a third-party appliance. You might have an on-prem network that you're trying to make sure that traffic for those IP addresses is destined goes back through your virtual network gateway or maybe a third-party VPN appliance. So those would be the common scenarios for routing. Basically anywhere that you're looking to override the default routing that's configured when you create or peer your VNets in Azure, you're going to start looking at custom routes that way. So I've got a couple virtual machines that I'm going to just look through the different effective routes that are applied to these VMs. So on this virtual machine, what I'm trying to do is force all my traffic through an Azure firewall in my hub. And so I have a route here that's directing everything all traffic that's not part of my virtual network to go through my Azure firewall based on the rules that I've defined here. I don't have other routes listed in here because this 000 route is overriding those default routes that Azure would have created. But if I look at another virtual machine, we'll see some difference in the routes. We should see some difference here. Oh, it's looking the same. So I guess what I wanted to show is that if I have another spoke virtual network where I have a route table deployed and I've said that I want to allow routes from my virtual network gateway to propagate through to my spoke virtual machines, then I would see routes like, say, my on-prem address space is 172.16/0/0/24. I would see a route here listed, and my next hop would be a virtual network gateway by default. And because, so that would be kind of default behavior. But if I wanted to force that traffic instead through an Azure firewall first before it was allowed to go on-prem, then I would need to have a custom route created to override that behavior. And so this effective routes is a place where you can see those applied routes. And lastly, so when talking about how we create custom routes in Azure, we use a resource called a route table. So a route table is a resource that contains one or more custom routes and is associated with a subnet in Azure. So all the devices within my subnet would use the same routes that are defined in my route table. So here I can have the route, I see the route that we were looking at applied to one of my spoke virtual machines where I'm routing all my traffic through an Azure firewall that has this specific IP address. All right, so let's move on. I think we talked about route tables. I want to make sure we have enough time here. Brandon, can I hand off to you and we can go through a summary of what we've talked about here?
Sure, awesome. So we've talked a lot about the different tools. What I want to leave you with is kind of some three guiding lights. One is to plan your virtual networking to take advantage of the tools and practices. Just don't import your heritage network. Don't just emulate what you're doing in your data center in Azure. Be aware of the tools and how they work for security, routing, and troubleshooting. There's a lot in there that you can use to accelerate your adoption of the network and to be in a really good position. So use those tools and be aware of how you can use them. And then lastly, look at leveraging a hub and spoke topology and the practices for security management and cost consolidation. Doesn't mean you necessarily have to do it, but looking at it, looking at the pros and cons, and making a thoughtful architecture decision is really going to help you with your adoption overall. So incredibly helpful to just kind of keep these three things in mind as you're going in. And with that, I think we are ready to talk about some other content.
Yep. Yeah. So again, just wanted to call attention to this collection on the Learn site. You can access it via this link here. It's been coming through the the chat and scrolling across the screen, or you can use the QR code there. But this collection has, again, more Learn modules that you can use to kind of add to the topics that we've, started talking about here. And there's also other resources that can kind of extend your learning and take it to the next level available there. So if we hop to the next slide. And we just want to call out that the next Learn Live session is going to be around modern service operations, and that'll be in a couple weeks after Ignite. But you can register for it at the links that are available here on this page. And also calling out that initially the recording for this networking session that we just went through will be available on YouTube. But you'll also be able to access it later on the Learn Microsoft Learn site. And let's see, lastly, just want to thank our moderators who've been helping out with questions in chat. Alejandra and Hubert, really appreciate the answers to the questions that you've been giving out there. And I think we can go ahead and wrap up here. Thanks, everyone.
Thank you all. Take care.